Welcome to your third video in this lesson from Chapter 3, and we're going to combine a couple of the different topics here. First, we're going to talk about the properties, and since exponential and logarithmic equations are inverses, a lot of their properties are related, and we can go back and forth between them to use them to solve our equations or rewrite expressions. So the following properties should not be new to you, however, they need to be memorized. This particular part of the lesson is from lesson 3.3, and you must memorize these formulas, these properties, so to speak. But let's look at a few of them just to refresh your memory. You learned this one last lesson, where if you have the base here of the log a to the y equals x, and you will go back and forth between that, the different directions. You've also learned that the natural log with base a of 1, the log of 1 is always 0 because a to the 0 power, any number to the 0 power, is 1. These right here should become second nature to you. If the base and the value are the same, then you know the log value is 1. Let's just review some of the high points here. If you have a log, base m to the r, you are able to pull that r, that exponent, out in front. And we very often do that. We sometimes go the opposite direction, and we're given this, and we'll kick it back up to the exponent. But that's called the power property. Other times you'll see a log that's written with values that are multiplied, and you will expand it by addition. So if they're multiplied, you expand it by adding each term. If you have 3 terms multiplied, you would have the sum of 3 terms. They start, when they're condensed, they're multiplied, so we call it the product property. This is similar if you are dividing initially, and you don't just have 2 terms, you can have more, but if you are dividing the terms and you're taking the log, then when you expand them, you will take the difference. Okay, it will be the difference, and the product is the sum. That looks like it's plus or minus, and I don't mean that. I just meant to highlight it. So I'm going to erase that because I don't want you to think it's plus or minus. I just want you to know that we are subtracting here, and that's the quotient. This makes sense. This is just kind of common sense. If you're taking the log, same base of one value, and it equals the log, the same base of another value, then that m and n are equal. And if you have the, you can go the opposite direction. That's called a one-to-one property. Also, if you have the, in exponential terms, if you have the same base and your exponents vary, but they are equal, then you know those exponents are equal. And that's very helpful when you're solving equations. If you can establish the base to be the same, then you can just play with the exponents, make them equal, and solve for the variable. This particular one, the change of base. The change of base formula, I know a lot of you forget it because there is a command on the calculator that will allow you to just plug in the new base, and very often you have forgotten the change of base formula. Please don't forget it. Your calculator will not always be available, especially when you get to calculus, but you need to know how to change the base. You want the base to be 10, obviously, because it's so much easier, but if it's not 10 and you want to solve it, then you take the base goes to the bottom. You take the log of the base, and that is the divisor. The dividend becomes the log of the value that you were taking the log of. So that m goes on top. I always remember base goes on the bottom, the 2 b's. So it would be the log of the base goes on the bottom. Okay, please don't forget that formula. Some of you are going to get out of habit of using it, and I'm encouraging you to use it. It will help you, hint, hint, in the future. All right, so this particular lesson simplifies expressions using these properties, expands and condenses expressions. So let's try a couple examples here. If I gave you an example of log base 6 of the third root of 36, and I would like to know the answer. Yes, I know you can put that in the calculator. I don't want you to do that right away. You need to learn to do this yourself. So let's rewrite it. I'm going to make that equal to x, and I'm going to say 6 to the x equals that. Right? So 6 to the x equals the third root of 36, and I'm going to write 36 to the 1/3. Now I know that 36 is 6 squared. So if I have 6 squared to the 1/3, that power to the power, that equals 6 to the 2/3. And one of our properties up there stated that if the base is the same, then and they are equal, then the exponents are the same. So then x must be 2/3. Let's look at this one. This one is expanded. It has a sum, and I notice that there is a 4 in front. Well, that 4 from one of our power properties can come up here, right? So it would be the power of the power. So I'm going to rewrite that natural log of e to the 9 plus the natural log of e to the 3rd, but that is going to go to the 4th power. Power to the power is you multiply. So I have the natural log of e to the 12th, and I have the natural log of e to the 9th. Now I have a sum. They're both natural log, both e to the power. The sum I can condense by the product property, and I can make that I multiply them. So that's equal to the natural log of e to the 9th times the e to the 12th. You notice I condensed it. I only wrote the natural log once. When you have the same base and the exponents, you're multiplying them, then you add the exponents. So we have the natural log of e to the 21st. And if you don't remember from your properties, but I can look at that and I know exactly what the answer is. If you forget, and you forget your properties, but you remember that the natural log is log base e, you can rewrite this as, if you already know the answer, you can write that down. But if you don't, you can write the natural log, or log base e of e to the 21st equals x. And then you can rewrite this with your exponent and logarithm property. So it would be e to the x equals e to the 21. E to the x equals e to the 21. Therefore, x is 21. Now, I want you to get to the point where you can look at this right here, and you see the natural log of e to the 21st power is 21. You need to get there, but if you're not there yet, you can go this route. All right, let's expand some. Using the properties, if you have problems here that are all multiplied, so all of these terms, let's see, this example says log base 13 of 7, the product of 7, a to the 3rd, b, and c to the 4th. So I have 4 terms there that are all multiplied together. So when I expand it, I need to make sure I have all 4 terms. Okay, so I'm going to expand this first one right here to be the log base 13 of 7. Now, it's a product, so I expand it with a sum, and then you write the log again, log of base 13 of a to the 3rd. Now, where could I have put that 3? I could have put that 3 in the very front, right? So I'm going to squeeze that in right there, because that 3 is a power, and that's using another property, but the power property brings it out in front as a coefficient. All right. Then let's look at this one. I just have b, the exponent is a 1, so I'm just going to write that as log base 13 of b. Last term, sum of, now this is c to the 4th, so I think I will remember to bring the 4 down first this time, and get log base 13 of c. You're done. You may say, why would I go to all the trouble to expand it that way? Sometimes when we work problems, we need to expand it because we're just changing part of it. And up here, it's hard to pull out one piece. If you have it expanded into the separate parts, you can vary one part and one variable a lot easier. Also, make note that every time I wrote in log base 13, don't leave that out. Don't assume that I'm going to see it over here and I'm going to think that you know that it goes there. If you don't have it there, I'm going to assume that you think it's a 10 and that you need to write in the base. Okay? Now let's look at this one. This is obviously written as a quotient, and so when we expand it, we know we're going to do a difference. When you expand it, if you'll notice, this numerator is one term. It's written in parentheses. So I can expand that with the natural log of the 3y plus 2 minus. Okay, I don't need to pull that apart and play with it. That is one unit together. Now in the denominator, I do have 2 units. I've got the 4 and I've got the third root of y. So I need to keep those separate. Now these are in the denominator. So I have this numerator minus the first term, which is going to be the natural log of 4, and then I'm still in the denominator, so I'm going to subtract again this problem right here. Now, do you remember that that third root can be written as y to the 1/3, right? So I'm going to bring that 1/3 out front, make that minus 1/3 natural log, don't leave that out, of y. Now I'm done. Now, you can go back and forth. I could have very easily given you this part of the equation and asked you to give me the condensed version. Okay, so you need to be able to go both directions. We're going to try a condensing one here, but you need to be able to go back and forth. Let's try this one and let's look at what we notice. This one is negative. And this term, we just have 2 terms here, and this one is positive. Well, I know that if I have the terms that are, if I have a difference of terms, I can write them as a quotient. So the first thing I'm going to do is I'm going to swap them. I'm going to put the 3 log base 2 6x first, minus the 5 log base 2 of x plus 1. Then I also notice I have a 5 and a 3 in front. I'm going to rewrite those as the exponents. So I'm going to do a couple things in one swap here. First, I'm going to rewrite this as log base 2 of 6x, and I'm going to bring that 3 up top. Then I'm going to subtract this term, but I'm going to bring that 5 up top. So I have the log base 2 of the x plus 1 to the 5th. So I did a couple things. I swapped the position and I used the power property to bring the exponents up. Now I simply have 2 terms with the same log base, and I'm taking the difference so I can combine them by division. So that becomes the log base 2 of the 6x to the 3rd divided by the quantity of x plus 1 to the 5th. Now, in simplified terms, we would prefer that you cube that out. And you take 6 to the cube to the 3rd power, which is 216 x to the 3rd divided by the x plus 1 to the 5th power. Now, I did not do that totally correct because I need to include the log in front. You cannot assume that I'm going to have that there. You have to write that in each time. Okay? That would be a better answer when you cube that 6. All right? When you come back, we will work with some equations from section 2.4.